Hello, good afternoon to all. My name is Yojit. I am from CSCC section from Srinivasa Ramanujan Institute of Technology. I am here to discuss about hydroelectric power plant. Whenever we discuss any power plants, the major process is the conversion of one energy to another energy. This slide shows the importance of energy. Energy is the backbone of socio-economic development, revenue generation, and improving quality of life worldwide. Meeting growing demand while reducing carbon emissions demands a decisive shift away from fossil fuels. We are now moving from fossil fuels and we are moving towards a sustainable energy and sustainable future. Economic growth. We are seeing economic growth in power industries, infrastructure and livelihoods. Climate imperative, reducing greenhouse gases like carbon, nitrogen, demands clean alternatives. We have to search for the alternatives in the coming generations. And next is sustainable future. Non-fossil fuel sources are the path forward. We have to move from fossil fuels to sustainable future like solar, wind energy, solar energy, where the efficiency is less but we have to produce more. We have to see the statistics of India's power landscape. India's total installed capacity stands at 3,14,640 megawatt with thermal dominating the mix, but renewables are rising fast. As we observe these statistics, by hydroelectric power plant, we are generating 44,187 megawatts clean base load. Means it is producing the one-third of electrical energy to the India. The highest number of megawatts is generated by the thermal power plant, which is 2,14,655 megawatts. It is the largest share in India's landscape. Now we shift from nationwide to statewide. I am particularly considering a state here called Kerala. Kerala total installed capacity is 2,880 megawatts with hydropower forming the overwhelming majority. In Kerala, the generation of electricity is majorly done by the hydro power plant, which is 73%, and followed by the thermal power plant and wind power plant and solar power plant with negligible amount of production of electrical energy. Next, we can see we can elaborate the Kerala hydroelectric power plant view. Kerala is blessed with 6,000 megawatts of estimated hydro potential, yet only 2,104 megawatts has been produced or harnessed, barely one third of what is available. Why this is because of environmental barriers, thermal constraints, strategic priority. We can consider forest and environmental clearances, restrict new hydro development, Land scarcity and coal linkage issues limit thermal additions. Now I'm going to share a topic about advantages of hydro power plant. Renewable and non-polluting. We can reuse or renovate the hydroelectric power plant, and it is totally non-polluting, zero emissions, environmentally begin energy generation. System reliability, instantaneous start, stop and flexible load handling. We can pass through the water through the pipe and we can generate electricity by rotating the turbine, and long lifespan, usual operational life exceed 50 years. And next one is fossil fuel conservation. We are searching for alternative for fossil fuel conservation, which is hydroelectric power plant. Regional development, we can operate it any economic avenues in remote and any urban areas. That's why Kerala taken a key initiative that Kerala government has allotted 25 small hydro projects to private developers under a build, own, operate, transformer boot model, efficiently harnessing the state vast hydro potential without burdening public finances. In this project, they are considering three main topics like build, developer construct the plant at their own cost, operate and own, developer operates and earns revenue over the concession period, transfer, ownership reverts to the government and the concession ends. Now we take the role of electrical engineering perspective in hydroelectric power plant. Hydroelectric plants are marvels of electrical engineering, convert the kinetic energy and potential energy of water into usable electrical power through a cascade of precision components. As I mentioned at the start, everything is the conversion of energy from one energy to another energy, like kinetic energy into potential energy, and potential energy into kinetic energy, and kinetic energy into electrical energy. We can see in a broader way that conversion of energy produces different types of power plants with respective conversions. As we are discussing now on the hydroelectric power plant, we have to generate the water flow using penstock, and penstock is passed to turbine to rotate the turbine to for by rotating the turbine, we are generating mechanical energy, means converting of potential energy into kinetic energy and kinetic energy into mechanical energy using turbine. And turbine is connected to generator where rotor rotates and electricity is generated in the generator, and the electricity is transferred by the transformer and the switch gear. We are harnessing nature's power naturally from reservoir to grid. Water's gravitational descent spin turbines, drives generators, and delivers clean electricity across transmission lines to homes and industries. We have to consider every step from now onwards is that the future is should be renewable, or else we are going to fall apart. Hydroelectric power, especially small hydro projects, is central to India's sustainable energy roadmap. By embracing clean generation technologies, we build a future that is cleaner, more reliable, and economically resilient. We should be maintained cleaner, more reliable. We have to use anytime, anywhere, and economically resilient. Low operating cost and long life.